Hello students, let us continue the session on understanding quadrilaterals. We have solved two questions of the second exercise. Moving on to third question, how many sides does a regular polygon have if the measure of each exterior angle is 24 degrees? We all know that each exterior angle is given by sum of all exterior angles divided by the number of sides. So here the measure of each exterior angle is given as 24 degrees. Sum of all exterior angles is 360 degrees. The number of sides, I'll take it as n. So we can find n as 360 divided by 24, which will be equal to 15. So this regular polygon has got 15 sides. Thus, the regular polygon has 15 sides. Question number 4. How many sides does a regular polygon have if each of its interior angles is 165 degrees? When we look at any polygon, if this is considered as an interior angle, its linear pair will be the exterior angle. This is exterior, this one is interior. Therefore, interior angle plus the exterior angle is 180 degree by linear pair. So interior angle plus exterior angle, this will be 180 degrees because of the linear pair. They have given the interior angle as 165, so we can find exterior angle. So exterior angle will be equal to 180 minus 165, which is 15 degrees. Once the angle is found, we can find the number of sides like the previous. The number of sides will be equal to the sum of all exterior angles, 360 degree, divided by the measure of each exterior angle, which is 15 degree. We get it as 24. Thus, the regular polygon has 24 sides. Question number 5. There are two sub-questions. The first sub-question is it possible to have a regular polygon with measure of each exterior angle as 22 degree? The second sub-question is, can it be an interior angle of a regular polygon? Why? Let us answer separately. The first one, they have given that exterior angle as 22 degrees. Once the exterior angle is there, we can find out the number of sides. The number of sides is given by sum of exterior angles upon each exterior angle. Here the sum of exterior angles is 360 divided by, they have given the angle as 22. On calculating this, we get it as 16.36. Very importantly, we must identify this particular part. This is 0.36. Can the number of sides be a decimal? It can't be. So we can mention here, no, we cannot have a regular polygon with exterior angle 22 degree, as it is not divisor of 360 degrees. Or you can also write the number of sides can't be decimal. Second sub question, can this be an interior angle? Suppose if I consider the interior angle as 22 degree, I can find the exterior angle. The exterior angle will be 180 minus the interior angle, which is 22. We'll get it as 158. The number of sides is now 360 divided by 158. Again, n will be a decimal because it is not an exact divisor. Therefore, I can say that it cannot be interior angle. Question number 6. The first question here is, what is the minimum interior angle possible for a regular polygon? Why? The second sub question is, what is the maximum exterior angle possible for a regular polygon? Let's answer the first one. We all know that the smallest regular polygon is an equilateral triangle. In an equilateral triangle, the number of sides are 3. Therefore, the sum of interior angles is 180 degree. Each interior angle we can find, each interior angle will be the sum of interior angles divided by 3, which is 60 degree. So how do we put it in words? The smallest polygon is a triangle and smallest regular polygon is an equilateral triangle. This is the smallest polygon we can make using 3 sides. 3 sides is the minimum. Sum of interior angles is 180 degrees. Therefore, each interior angle is 180 degree divided by the number of sides, which is 180 degree divided by 3. This will be equal to 60 degrees. Let's answer the second sub question. For an equilateral triangle, each exterior angle will be equal to 180 degree minus 60 degree. This will be 120 degree. So the maximum exterior angle possible is 120 degree and the minimum interior angle possible is 60 degree. Very important question, you must note. Moving on to exercise 3.3. These are the questions related to properties of quadrilateral. First question is, given a parallelogram ABCD, complete each statement along with the definition or property used. First one, AD is equal to AD and BC, they will be equal to each other, they are the opposite sides. So for the first one, AD is equal to BC, the reason is the opposite sides of a parallelogram. This is a shorter notation to write parallelogram of a parallelogram are equal. Second sub question, angle DCB will be equal to, look at angle DCB, this angle and angle DAB, they are equal because the opposite angles of parallelogram are equal. Opposite angles of a parallelogram are equal. The third sub question, OC will be equal to, OC is a part of the diagonal AC. Here, this part OC will be equal to the part OA. The reason is the diagonals of the parallelogram bisect each other. I can also say that DB bisects AC. I can mention that is diagonals bisect each other. Hope I have made it clear. The fourth sub question, the measure of angle DAB plus the measure of angle CDA is equal to, understand that this angle DAB and CDA, they are the adjacent angles. These two angles are adjacent to each other. They will be supplementary. Remember, in class 7th you have learned that the interior angles towards the same side of transverse, that is co-interior angles, they will be supplementary. You can mention here co-interior angles are supplementary. Second question, consider the following parallelograms, find the values of the unknowns x, y and z. First one of the angle of the parallelogram is given as 100 degrees. We need to find the other three angles. You must make use of the properties of the parallelogram. We know that the opposite angles of parallelogram are equal, so y will be equal to 100 degrees. It's very important to mention the reasons in geometry. The reason here is opposite angles of parallelogram are equal. Now, I can make use of this x plus y as 180 degrees because they are the co-interior angles, or you can also write adjacent angles, co-interior angles. Y value is known to us, so x will be equal to 180 degree minus 100, which will be 80 degrees. So y value, x value are found. We can find the value of z. Z will be equal to x. This will be equal to 80 degrees. The reason is the opposite angles of parallelogram. So we have found x as 80 degrees, y as 100 degrees, and angle z is 80 degrees. Second sub-question, observe very carefully. One of the angle mentioned is 50 degrees here. We need to find angle z, angle y, and angle x. Since adjacent angles are supplementary, I can make use of this. X plus 50 degree as 180 degree. I'll write the reason as co-interior angles. So x will be equal to 180 minus 50, which is 30 degrees, sorry, 130 degrees. Then I can make use of y is equal to x. This will be equal to 130 degrees. The reason is the opposite angles of parallelogram. Now I want you to observe carefully. These two are the opposite sides. They are parallel, and if I extend this line, it acts as a transversal. Whenever a line or a transversal cuts two parallel lines, the pair of corresponding angles are equal. So here x will be equal to z. They are the corresponding angles. So they will be equal to 130 degrees. Therefore, x value is 130 degrees, y value is 130 degrees, and the value of z is also 130 degrees. Third sub-question. We need to understand that this is a symbol used for mentioning 90 degrees. So whenever two lines they intersect each other, the pair of vertically opposite angles are equal. Here x will become equal to 90 degrees because they are VOA, that's vertically opposite angles. Now I want you to observe there's a small triangle. In the triangle, the sum of interior angles is 180 degrees. It's called as angle sum property. Of triangle. I am taking this triangle which is shaded here. So x is 90 plus y plus 30 degree equal to 180 degrees. So y will be equal to 180 degree minus 120 degree, which is 60 degrees. So we have found the value of y. Now I want you to observe carefully these two sides. They are the opposite sides. If opposite sides are parallel, the pair of alternate angles are equal. So y will be equal to z, and this will be equal to 60 degrees. The reason is they are the alternate angles. Therefore, we have found x as 90 degree, y as 60 degree, and the angle z is 60 degrees. Fourth figure, you need to just see these are the parallel sides and there is a transversal, so the corresponding angles are equal. Z will be equal to 80 degrees. The reason is they are the corresponding angles. Now I want you to observe Z is same as Y, which is 80 degrees. The reason is they are the alternate angles. X plus 80 degrees is 180 degrees because they are the co-interior angles. So x will be 180 degree minus 80 degree, which is 100 degrees. So we have found x as 100, y as 80 and z as 80. Fifth one, observe they have mentioned two of the angles. We need to find x, y, z. It's very clear that opposite angles are equal, so y will be equal to 112 degrees. The pair of opposite angles of parallelogram are equal. Now you just see this triangle, y plus 40 degree plus x will be equal to 180 degrees. That's because of angle sum property of triangle. Therefore, in the place of y, we'll write 112 plus 40 plus x is equal to 180 degree. So x will be equal to 180 degree minus the sum here is 152. So when 152 is subtracted from 180, we get x as 28 degrees. So we have found x value and y value. Observe z will be same as x. They both are alternate interior angles. Alternate interior angles. I'll end this session with a question for you. Can a quadrilateral ABCD be a parallelogram if D plus angle B is 180 degree? Second is AB equal to DC equal to 8 centimeter, AD is 4 centimeter, BC is 4.4 centimeter. Third one, angle A is equal to 70 degree and angle C is equal to 65 degrees. I want you to think about the answer. We'll solve the same question in the next session. That's all for today's session. Thank you.